In part 5 of our lesson on translations of sine and cosine, you'll learn how to write the equation for a function given its graph. In this example, we have to determine two possible equations for the graph, one cosine and one sine. So let's start off by jotting down the standard forms. We know we'll have y equals a sine of b times x minus c plus d, or it will have to be y equals a cosine of quantity b times x minus c plus d. And our job is going to be that we have to find a, b, c, and d. We know that a comes from the amplitude, and we know the definition of amplitude is that it's equal to 1/2 of the max minus the min. Now, when we look at this function, we see the maximum is here at 5, and the minimum is here at -5. Remember that amplitude is the absolute value of a. So we have 1/2 of 5 minus a -5, so of course that becomes plus, and this is 10 inside the parentheses, and half of 10 is 5. So we know the absolute value of a is 5. So a could be positive or negative based on whether the graph is flipped or not. And when we look at this graph, we see that it's going up first. So say this was a sine, we see that it's going up first to its maximum. So this has not been flipped. Now, if this is a cosine graph, we'll talk about how to handle that in a little bit. That would mean it would be starting here. And again, that graph would not be flipped. So a is going to be +5. And that's because the graph is not flipped. So now we already know what letter A is in each case. We know that B comes from the period, and when we're looking at a graph, we can find the period by subtracting the end point minus the start point. So we know the end point of one cycle is here at 7 pi over 8. The starting point is negative pi over 8. So 7 pi over 8 plus 1 pi over 8 is 8 pi over 8, which of course is pi. So we know that the period is equal to pi. Now we know at this point we can set 2 pi over b has to equal pi, because that's another way to find the period. If we cross multiply the b up and cross multiply the pi down, we'll have 2 pi over pi is equal to b, and we'll get that b is equal to 2. So far we already know a and b. Now c will be different depending on whether it's a sine wave or a cosine wave. So let's do letter D first, and then we'll talk about c. So we know the vertical shift by looking at the graph here Well, the center line of the graph is still on the x-axis, so there is none. So that means that D is equal to 0. Now let's talk about the phase shift. If this is a sine graph, then we know that a sine graph, normally what is happening at the y-axis is that the root should be there. So for the sine graph, the phase shift is going to be left by pi over 8. So that means that C would have to equal negative pi over 8. If C is negative, remember what that means. You write it as x minus negative pi over 8, which turns into x plus pi over 8. So if we're writing a sine graph, let's see what that would be now. We have y would equal, we found a is equal to 5 times the sine of the quantity. B is equal to 2. We just found that the phase shift was going to the left by pi over 8, which means C is equal to negative pi over 8, which means you write x plus pi over 8 in your equation. And the vertical shift was 0, so there's nothing to add on there. So here's the equation of the sine graph. Now, if this was a cosine, and we wanted to look at the phase shift, we know that at the y-axis, what normally happens for the cosine is that it would be starting at that maximum value. So that means if this is a cosine graph, it's shifted to the right by whatever this first dotted line mark is. And of course, if this is negative pi over 8, then this one is going to be positive pi over 8. So if this were a cosine graph, then the phase shift would be to the right by pi over 8, which means that C is equal to positive pi over 8. And remember that C is what comes after the minus sign, so then you would write it in the argument as x minus pi over 8. So we can come up here now and write our cosine equation would be y is equal to, we said a is 5 times the cosine of the quantity, b is 2, x minus pi over 8, and the vertical shift is none. So something important to notice, the only difference between a sine wave and a cosine wave for the same picture is the phase shift. The amplitude is the same, so A will be the same. The period is the same, so B will be the same. The vertical shift will be the same. It's just in this case there was none, so D is equal to 0. So the only thing that will be different for these graphs will be C, because the phase shift is different. Sine wave went to the left by pi over 8. That's why it's x plus pi over 8. Where cosine would have had to go to the right by pi over 8, and that's why it's x minus pi over 8. So in this next example, we have to again determine two possible equations for the graph, one cosine and one sine. So as before, we know we're going to write one in the form of y equals a sine of b times x minus c plus d, and we'll have to write a second one in the form of y equals a cosine of b times x minus c plus d. And your job is to find a, b, c, and d. So why don't you try this one on your own now, pause the video, and then restart when you're ready to check your answer. We can find the amplitude by using the definition that it is 1/2 of the max minus the min. Looking on the graph here, it's going to be 1/2. Now the maximum occurs here at a y value of 6. The minimum occurs here at a y value of 1. So we know the amplitude is going to be 1/2 of 5, which is 5/2. Now we know that amplitude is the absolute value of A, and once again, this graph has not been flipped, so that means A will be positive. We'll just make a little note to ourselves. That's because it's not flipped. That's why it's positive. All right, so we already know A for each one. We could start writing that in if we want to. Y would be 5/2 times the sine, and I'll leave the rest blank for now. We'll fill that in as we go. And then over here, y will be 5/2 cosine of something, of course, but we're leaving it blank for right now. Next, we can find the period. We know that we're going to do the end value minus the start value. And looking at the graph, we see that it ends at 6 pi. It starts at 2 pi. So that means the period is going to be 4 pi. Now we know when we're doing a calculation that period is 2 pi over b. We'll cross multiply the b up, cross multiply the 4 pi down. So we would have 2 pi over 4 pi is equal to b. The pi's are going to cancel, and 2 over 4 reduces to 1/2. So now we know b is 1/2. We can start to fill that in. So as we did last time, let's go ahead and find the vertical shift first. Now, the vertical shift is tied to where the center line of the graph is. We know that halfway between the maximum and the minimum is going to be the vertical center of the graph, and that will give us our vertical shift. So D is going to equal the average of the minimum and the maximum. It's going to be exactly halfway between the smallest y value and the biggest y value. So if we take the minimum plus the maximum and divide it by 2, we have 1 plus 6 divided by 2 is equal to 7/2, and that's our value for D. So we can leave a space and put plus 7/2, leave a space and put plus 7/2. Now the only thing left to find is going to be the phase shift. Now this looks most like a cosine wave, so let's go ahead and find the phase shift for cosine first. We know that normally cosine would have its maximum over here on the y-axis, so this point would be over here, so that means that the graph must have shifted to the right by 2 pi. If it shifted to the right, then that means that C has to be positive 2 pi, and when we write it in our argument, it's going to look like x minus C, so we put the 2 pi there. So we can go up to our equation here and enter 2 pi. Now, if instead it were a sine wave, then let's look at that phase shift. With D equaling 7/2, let's get that on the graph here. If D is 7/2, so that would be the same as 3.5 when I'm looking at the graph. So 1, 2, 3.5. So 7/2 or 3.5, doesn't matter which one you write. So this is sort of the center line of the graph. We know that sine, if this were a sine wave, it would be ending right here. So this would be the end point, this would be the 3/4 point, this would be the midpoint, this would be the quarter point. We know the period is 4 pi. So if the sine wave is ending at 5 pi and the period is 4 pi, that means it began over here at pi. So if this were a sine wave, we know that normally sine would start out here on the y-axis with this root that's been shifted up. So it would start here, which means then that the sine wave has been shifted to the right by pi. Since it's going to the right, that means C has to be positive pi, and when we write it in our argument, it looks like x minus pi. So we can come up here to the sine equation now and fill in the value for C. So we have our sine equation, y equals 5/2 sine of the quantity 1/2 x minus pi plus 7/2. And we have our cosine wave, which is y equals 5/2 cosine of 1/2 x minus 2 pi plus 7/2. So once again, we notice that the only difference between these two is the phase shift. The amplitudes are the same, The periods are the same, so that means B is going to be the same. The vertical shift is the same. The only thing different is the phase shift. If it's a sine wave, it had to shift to the right by pi. If it's a cosine wave, it had to shift to the right by 2 pi. Also, notice how the amplitude works. The distance from the center line up to the maximum is 5/2, or 2.5. And the distance from the center line down to the minimum is also 5/2 because the amplitude is 5/2.